In this task, we are going to consider the following function u equal to x1 to the power of alpha. And we are going to consider, is this function a Lebesgue function? More precisely, is it a L2 function? And in order to find the answer to this question, we have to compute this integral, as we know. And we know that if this integral is finite, then it's, of course, a Lebesgue function. If it's not, it's not finite. If it's infinitely large, this integral, then this function cannot be a Lebesgue function. So in order to compute this integral, what are we doing? Well, let's recall the following. The primitive function of x to the power of n, where n is any constant, is just equal to 1 over n plus 1, x to the power of n plus 1. And this is only the case when n is different from minus 1. If n is equal to minus 1, then we have that the primitive function of this x to the power of n is just equal to the natural logarithm of x. So now we are assuming that x is a positive function, so we don't have any problem with negative values here. We know that the logarithm of negative values is not defined anyway. So let's now compute the integral of from 0 to 1 of this function x to the power of n. This is equal to, instead of using 0, I just use a positive number a instead, a small positive number, because if n is a negative value, then x to the power of n turns to infinity when x turns to 0. So we want to avoid that. So I'm just, instead of computing this integral from 0, I compute it from a to 1 instead. And what we are going to do is just letting a go to, when we have computed this integral in terms of a, we can go to the limit in, let a go to 0, and then we find the limit of this integral, which then turns out to be equal to the integral from 0 to 1. So let's just do that. When we are using these primitive functions here, we know exactly what the integral from a to 1 is. It's just equal to, we have in fact 3 different cases. The first cases are when n is different from minus 1. So let's consider this first. Maybe I just write it. Yes, I can write case n larger than minus 1. What's happening then? And this integral just just turns out to be equal to 1 over n plus 1 x to the power n plus 1, and we're taking the limits from a to 1. And what's happening then we are having 1 over n plus 1, and inside here we have 1 to the power of n plus 1 is just equal to 1, so I don't write this, and minus a to the power of n plus 1. So in this case, what's happening here is that when a goes to 0, then this just goes to 1 over n plus 1. So this approach is just this number. Let's now consider the next case when n is less than minus 1. So n case n is less than minus 1. What's happening then? Well, now we have that this integral is equal to, let me write this, the integral from a to 1 of x to the power of n is just equal to, and we have 1 over, similarly as in the first case, 1 over n plus 1, and we have 1 minus a to the power of n plus 1, exactly as before. But note that no n is less than minus 1, so this exponent is a negative number. And what does that mean? It's maybe easier to see what's happening if I write it like this. 1 over 1 n plus 1 multiplied with 1 minus, and what I'm doing now is just to take 1 over n to the power of minus n plus 1. This is just for you to see what's happening, because now, since n plus 1 is a negative number, this exponent is a positive number. So when a goes to 0, this value is approaching 0. So now you see that this value goes to infinity. This goes to minus infinity, and we know that n plus 1 is a negative number. So this negative number multiplied with something which is going to minus infinity turns out to go to infinity. Maybe a little bit difficult to see, but try to think about this for yourself. So what's happened here is that we had the situation when n was larger than minus 1. We obtained that the limit, this integral, the limit of this integral goes to 1 over n plus 1. But in the case when n is less than minus 1, we obtain that this integral is going to infinity. Okay, let's consider the final case. I can write this also. The case when n is equal to minus 1. So in this case, the integral from a to 1 of x to the power of n dx is just equal, we recall that the primitive function of this integrand is just equal to the logarithm of x. So we have the same limits a and 1, and what is this? This is equal to, so this is equal to the logarithm of 1 minus the logarithm of a. And recall what I said earlier, that the logarithm of a value, when this value goes to 0, is just equal to minus infinity. So minus the logarithm of a goes to infinity. This is just equal to 0. So this goes to infinity. So let me just now recall. We have the following situation. The integral of x to the power of n from 0 to 1. We agreed on that this is just the limit when a goes to 0, is just equal to, we had 3 different cases. It's equal to 1 over n plus 1 in the case when n is larger than minus 1. And it's equal to infinity when n is less than minus 1. And it's equal to infinity when n is equal to minus 1. Well, so what we now arrive at is the following. We wanted to compute this integral. And, well, we now have the value of this integral for the inner integral for all cases of n. And n in this case is just equal to this 2 alpha. So this means that the integral is just equal to, we have 3 different cases. The integral is just, we can now compute the inner integral, and it's going to be a constant, but well, let me write. I'm computing the inner integral. Here is just 1 over n plus 1 dx2. And I can insert, instead of writing n, I can insert 2 alpha instead. So this is when 2 alpha is larger than -1. So what does that mean? If I divide with 2 on both sides here, we obtain that this is the same as saying that alpha is larger than -1/2. So maybe I just write this instead, because I want to consider cases for different values of alpha, not different values of n, which I've used for the preparation of this. So this is the case when this is the integral that we get when alpha is larger than -1/2. If alpha is equal to 1/2, then n is equal to -1. And if alpha is less than -1/2, that is when n is less than -1, we obtain infinity in the integrand here. So instead of writing n, I also here write alpha less than -1/2. And we have this limits 0 and 1. So, and the last case is also if alpha is equal to -1/2, we obtain this integral from 0 to 1 of infinity of dx2. So what does this mean? Well, the integral of infinity from 0 to 1 is just equal to infinity. The integral from 0 to 1 of this constant is just equal to this constant multiplied with 1. You know, it's very easy to compute the integral of a constant, because then you just get the constant multiplied with a variable as a primitive function, so it's very easy to do. So what does this mean? We have 3 different cases. We have the case 1/2 alpha plus 1 if alpha is larger than -1/2 is equal to infinity if alpha is less than -1/2, and is equal to infinity if alpha is equal to -1/2. So this answers our question directly. The only case when this function u equal to x to the power alpha is a Lebesgue function, is a L2 function, is when alpha is larger than -1/2.